Welcome everybody to this lesson on sources of return from investing in fixed coupon bonds, a really important one from the point of view of later being able to appreciate concepts like duration, which are heavily tested. So let's start off with listing the three sources of return that you may expect to generate when investing in fixed coupon instruments. First of all, this is the most obvious one, I guess. Simply the receipt of scheduled coupon and principal payments. It's receipt of scheduled coupon plus principal payments. And I'm assuming, these will be paid on time. Then the second one is the reinvestment of coupons. So these coupons will be, reinvested. And third, although this is kind of optional, it's potential. The potential gain or loss on the sale of the bond. Obviously, if the investor decides to do that, if they decide to sell before the scheduled maturity date, before maturity. Now, it is going to be the latter two, this one and this one, so number 2 and 3, which are going to be potentially affected by changes in interest rates, changes in yields. And this whole video is going to be all about trying to gauge that effect, so to speak. Now, let me go back just a moment to a previous video that we did. One of the initial ones on the topic of bond pricing and actually measuring the yield to maturity as well. So we previously mentioned, and I asked you to believe me that this is the case, that an investor's rate of return, obviously from an investment in bonds, is going to equal the bond's YTM, its yield to maturity, if certain conditions are met. Number 1, all coupon and principal cash flows, payments are indeed received on time. Of course, the investor has to hold the bond to maturity. Holds bond to maturity. That's quite an obvious one. Otherwise, they wouldn't receive all the coupons and the principal payment. And the third one, which is kind of the most tricky of them all to satisfy, the coupon gets, or the coupon receipts, the money received under the coupons are reinvested at a rate equal to the YTM, right? And believe me, if this is the case, you will generate a rate of return equal to your YTM, your yield to maturity, or the bond's sort of original computed yield to maturity. However, in this video, we're going to think more about situations where the investor sells the bond prematurely. So they break one of the conditions here, they don't hold the thing to maturity. And the question is, what will happen to the realized rate of return, or the so-called investment horizon yield then? And there are some questions which we're going to explore over here. So we're going to tackle more than one question in this video. In fact, we're going to do 2 numerical questions to explore these concepts. The first one is, an investor purchases a 10-year 8% annual coupon bond. At the time of purchase, market interest rates are 10%. So that is going to give us the yield to maturity, 10%. After 3 years, the bond is sold. Okay, so sold before the maturity date. Assuming interest rates remain unchanged, meaning they are still 3 years later, they are still at 10% basically over the 3-year investment horizon. The investor's horizon yield is closest to. Now, we'll define horizon yield is basically the internal rate of return, or the rate of return realized over the 3-year period. Or it's going to have to be annualized. But let's work on this. First of all, we need to, say to ourselves that the investment horizon in this problem, because the investor chooses to sell after a 3-year period, is simply going to be 3 years. Okay, and let's calculate the purchase price. How much did they pay to get this bond? Because you can't calculate a rate of return on an investment if you don't know what the price going into the investment actually was. So I'm going to utilize our trusted and tested time value of money worksheet to do this. So when the investor was buying the bond, it had 10 years left until the maturity. It was paying coupons annually, so no need to do any semi-annual, doubling of periods. It had an 8% coupon, so PMT will have to be set to 8. What else? Our I over Y, so the yield was 10. Okay, we don't care about the bond being sold prematurely. We just need to enter the EV over here, 100. Okay, taking the calculator, clear the time value of money first. So second EV, now 10 for N, 8 for PMT, 10 for I over Y, of course in no particular order. You can input these numbers, and 100 for a V. And now get your calculator to compute. So CPT PV. Okay, out pops 87.711, so to speak. 87.711 more or less, and it's of course a bond that was purchased at a discount to par value. Why was there a discount? Well, the bond was only offering 8% coupon when investors were requiring 10%, so they made up the shortfall via the discount. That's the way it is. Now the next thing we need to compute is the selling price. After 3 years are over, what would be the selling price or the sales price of that bond 3 years into its lifetime? So because I'm told that interest rates remain unchanged over the 3-year horizon, there's only going to be one input that I need to adjust, and that's N. Now you need to set N at the time remaining to maturity, so don't do 3 over here. Well, when the bond was sold, it still had 7 years left to maturity, given that it was originally 10, right? Okay, and now, when you override the input 7 for N, CPT PV, I of course didn't clear my time value of money worksheet, so I still have the old inputs there from the previous computation, and you can see that the bond would have been sold for 90.263. Now, let's use this information to plot things on a timeline. Okay, we're going to draw quite a few timelines in this video. So, but really just to prove some points. Later on, we won't be doing so much of these illustrations. So over here is time 0, end of year 1, end of year 2, end of year 3, when the bond is sold, and I don't care about any other further dates. So over here, the bond gets sold for a cash inflow of 90.263, and of course it was originally purchased. Sorry, where was the price? Okay, here, 87.711. That was the purchase price, 87.711 at what I've designated to be time 0. And of course, in the meantime, there are these coupon inflows. The bond was supposed to generate 8% annual coupon per year, so on a 100 par value basis, that gives 8 plus 8 plus 8. These are my coupons over here, of course, in case you later get confused when you look at your notes. And that is, of course, our selling price. Okay, nice and clear. Right. Let's assume that these coupons were getting reinvested, and because the interest rate stayed flat at 10%, nothing was changing, interest rates remained unchanged, I'm going to sort of hypothetically assume that it was possible for the investor to reinvest each of the coupons at 10% as well. So, for example, this coupon received at the end of the second year would have been reinvested until the end of the third year at a rate of 10%. So in order to get its its year 3 value, we need to multiply that by a factor of 1.1, which actually gives 8.8. No need to take the calculator out. This one would have been once again reinvested at 10%, but for 2 years in a row. First year, second year. So this would grow by a factor of 1.1, but squared. And if we do this on the calculator, take 8, multiply by 1.1 to the power of 2, 9.68. Right. So effectively, at the end of the third year, what you have are the following, the following items of value. First of all, you sell the bond for 90.263, you get the final coupon, and you can liquidate your reinvestments of the prior year's coupons. And if we take all of this and add it up, let's see how much we have in total, what's going to be the sum over here. So I've got the 9.68, the bottom value on my calculator. I'm just going to add the remaining 3, plus 8.8 going from bottom up, plus 8 plus 90.263. Okay, 116.743. Good. Let's use this to compute what is known as the horizon yield. After all, the horizon yield was in fact what we were asked for over here, the horizon yield. Okay, your curriculum defines the horizon yield as the investor's internal rate of return. So the rate of return experienced by the investor, internal rate of return, based on the absolute total return. So that includes the sale of the bond, or perhaps its redemption if you hold it until maturity, but also the reinvestment of coupons, any intermittent cash flows. And that horizon yield is going to be always annualized. Whenever you quote yields, get used to the idea of them being annualized. Okay, so how do we do this? Well, you could use the time value of money worksheet. If you did, you would, let's do it actually, let me show you. So using the TVM, you would need to clear it first, of course. So second FV. Now, for FV, you would input 116 point, sorry, I was saying 16, I wrote 11.743, so this value over here. For PV, you would need to input the initial price that was paid, 87.711, with a negative sign. For the number of periods, and you would need to input 3, and you would need to make sure your PMT was set at 0, right? You don't receive anything. So you just have the initial cash flow and the cash flow at the end, which is a function of all the intermittent cash flows being reinvested and held until the end of year 3. Right, let's see what we would get. 116.743 for FV, 87.711 negative for PV, 0 for PMT. I actually didn't have to do that because I had my worksheet cleared, 3 for N, and now compute I over Y. Okay, and as you can see, this pretty much equals 10%. Nice. Which, by the way, is equal to the original yield to maturity on the bond. Even though we didn't hold the bond until the maturity date, we still managed to get an horizon yield, investment horizon yield, that was absolutely in line with the YTM. Right, let's do the same computation, but in a different way. What you could just as well do, and I think this is easier than using the time value of money, is to say this is equal to 116.743. So this amount divide by 87.711, that's the initial price paid, and take or raise this to the power of 1 over 3, that's like taking a root with the exponent of 3, and deduct 1. Let's see what we get when we do this. 116.743 divided by 87.711 equals, raise this to the power of, open bracket, 1 over 3, deduct 1, and as you can see, it's the same 10%, right? Whichever way we calculate it, so just choose whichever is more convenient for you. Right. The important message is that the realized horizon yield, what the investor managed to actually earn, is equal or was equal to the original YTM, the original yield to maturity, even though, let me write this down, even though the bond was not held to its maturity date. And you have to appreciate why this happened. After all, we broke one of the conditions previously laid out. Investor holds the bond to maturity. Well, now, in this case, they didn't. So how come the investor's rate of return was equal to the YTM? Well, two reasons are important. So let me say, even though, but the coupons were reinvested at 10%, which was the original YTM. And additionally, I think the most important point here is that the bond was actually sold for a price that was very specific, was sold for a price. Now I'm going to write something down and explain it in a moment, which lies on the constant yield price trajectory. Let me write trajectory properly again, trajectory. Now this second point is extremely important, and it's quite, it can be quite confusing. You may remember from an earlier lesson I did talk about something called the constant price yield trajectory. And basically what that is, maybe the graph will remind you of what it was. If this is the par value of a bond, and assumed 100, right? This specific bond was initially bought at a discount. It was bought for 87.711. So it was bought for a price that was evidently below par, right? However, I did in a previous lesson explain that what happens is, if yields don't change, if interest rates around us don't change, there is a process that pulls the price towards par value, towards the 100 as time goes by. So with the passage of time, what happens is we experience this phenomenon which is called the pulling of the bond price to par, or the pull to par, or the pulling of the price to par. And that only works when you've got constant yield, when interest rates don't change, or the required rate of return in the market is not changing. And the same thing will happen if you buy a bond at a premium. It will also be pulled to par. So we have a process due to which the discount, the original discount, which is quite heavy, or the original premium, which is quite big, gets amortized away and becomes less and less of an issue. Now, the thing is, if this was time zero, right, the point of purchase, end of year 1, end of year 2, end of year 3, this would be end of year 10. The price for which that bond was sold, let's see again what it was. Yeah, 90.263. It was calculated using the same yield assumption, using 10% as the yield assumption. So it was sold for a price that lies on the constant yield price trajectory. It's the price trajectory that we can draw if we assume yields stay the same and the only parameter we change is n. Over time, you'll see that price, that PV value, get closer and closer to 100. That's basically the idea, right? Okay. So, if you sell for a price that is on the constant yield price trajectory, that sales price, or that selling price, is said to equal the bond's carrying value. Okay. Because the carrying value is simply the original purchase price. In our case, that would have been 87.711 plus the amortized portion of the discount. As you can see, that discount, slowly original discount gets amortized, and after 3 years are over, after 3 years, a portion of it has already indeed amortized. So that's the case in the case of a discount, or in the case of a premium, we would simply minus the amortized portion of the relevant premium, if the bond were bought or acquired for a premium. So I guess this would be the amortized portion of a premium, were that indeed the case. And one thing I want you to appreciate is a capital gain or loss only arises if the bond is sold for a price different to its carrying value. We often mistakenly assume, sometimes candidates in the CFA exam, if asked in the fixed income section for a computation of the capital gain or loss, they think, okay, the bond was bought for 87.711, it was later sold for a higher price, 90.263, hence there is a capital gain. Well, that's not the way it works in bond mathematics. You only have a gain or loss if the price for which you sell is different to carrying value, but carrying value changes over time due to this amortization of the discount or the premium. Of course, if you buy a bond for exactly its par value, there is no amortization effect, so carrying value stays at the initial cost of purchase. So only if you sell the bond for a price which is either higher or lower, so a price that is either above or below that constant yield price trajectory, would there be a capital gain or loss? Something I'm going to explore in a while in a moment, effectively. Sorry for that. Okay. Let's move on to another example, or another question. An investor purchases the same bond, a 10-year 8% annual coupon bond, At the time of purchase, market interest rates are 10% once again, so that's our original YTM. And after 3 years, the bond is sold again. But look, this time, assuming interest rates increase by 50 basis points after the bond is purchased, so effectively they go to 10.5%, but before the first coupon is received, and subsequently remain at the new level until the end of the 3-year investment horizon. The investor's horizon yield, is closest to. So, because originally the yield was 10%, we know what the purchase price is or was originally. It must have been the same 87.711 that we already previously computed. So let me write that down. Purchase price, and this is something we know from the previous problem, must have been 87.711, like this. Now, if the bond, let me say this, if the bond was held to maturity, so held for the next 10 years, which this bond wasn't, right? The only thing that would happen would be that the coupons would be reinvested at the higher 10.5%, so higher than the original YTM, instead of the original 10%, and you would see that your horizon yield would be greater than 10%. You would actually realize something better than 10%. But this is not the case here, of course, because we sold the bond prematurely, or the investor sold it after 3 years. Also, let's say that if you hold the bond until maturity, there can be no capital gain or loss. So let me actually add this. No capital gain or loss, irrespective of what happens to interest rates, because ultimately you sell the bond, so you receive at the end of year 10, you receive the par value of 100, irrespective of what's happening to yields in the market, and that is a price on the constant yield price trajectory. Okay. Now, that aside, the bond was indeed sold when interest rates were higher, and of course we assumed that those interest rates went higher instantaneously before the first coupon was received, so we already had an opportunity to reinvest the first coupon at that higher rate. Let's take it step by step, just like before. We started with the purchase, didn't want to cross that one out. We started with a purchase price. Now let's compute the selling price. Okay, using the time value of money worksheet, of course. So after 3 years, we will still have 7 years left to maturity. Our PMT here will be 8. This is the 8% annual coupon bond. We will have an FV of 100 and a modified I over Y equal to 10.5. Now, because I've done some stuff on my time value of money worksheet, I'm going to clear it and input this data: 7 for N, 8 for PMT, 100 for FV, and 10.5 for I over Y. Compute PV, right. CPT PV gives 88.027. Okay, let's think about what happens to the on the timeline to our horizon yield. Just like before, we're going to use the same sort of approach. So I'm drawing a fresh timeline over here. Time 0, end of year 1, end of year 2, end of year 3, and this 88.027 is what we receive at the end of the year 3 from selling the bond. Of course, initially we paid that price of 87.711, and in the meantime we get these coupons. So the third coupon is received precisely at the end of year 3. The previous two are received earlier and had a opportunity to earn something from reinvestment. However, now, because the change in interest rates happened just before the first coupon is received, that will have an impact on how both coupons are reinvested. So over here, this one grows by a factor of, or it doesn't grow. To compute its future value, we multiply by 1.105 with the additional 50 basis points, and this one times 1.105 to the power of 2. Okay, let's do this. 8 times 1.105. So this will have, the second coupon will have grown to 8.84, and if I multiply that one more time by the same factor, 1.105, I'll get the value, the future value at the end of year 3 of that coupon from year 1, 9.768. Right. Let's get the totals in. This, and this. So let's start with the top one, 88.027 plus 8 plus 8.84 plus 9.768. That gives a grand total of 114.635. And just like before, I want to see what's going to happen to our horizon yield with this sum of cash flows. Nevertheless, we can already make some, initial comparisons relative to what we calculated before. In the previous version, we had a grand total down here of 116.743 for the cash flows. This time around, it's a lower grand total. So and it was still the same purchase price. So we'll have definitely a horizon yield that will not be as high. Let's calculate it nevertheless. The horizon yield is going to be this 114.635 divided by the initial price of 87,711. Okay, 3-year period, just like before. So raise this to the power of 1/3 and deduct 1. Okay, I've got the 114.635 on my display. So just to divide by 87.711 equals raised to the power, open bracket, 1 divided by 3, close bracket, equals -1. As you can see, it's 9.33%, which is definitely less than the YTM. Less than the YTM. Now, what is actually happening here? Well, there are two sort of conflicting effects taking place, or two mutually offsetting but not perfectly offsetting effects. Two offsetting effects, but not perfectly, right? On the one hand, due to the fact that we've got a lower yield now, also increase higher rates, the coupons are being reinvested at that higher rate. Coupons reinvested at a higher rate, which produces more of that future value at the end of year 3. Now we can quantify that because, initially the coupons getting reinvested, these were the reinvested coupons, 8.8 and 9.68. So they were amounting to, let's say, 18.48. The value of these reinvested coupons. I'm leaving the the single 8 over here. That's not working at all at the YTM, at the yield to maturity, or indeed the changed yield. Whereas over here, these reinvested coupons were giving a grand total, which is going to be bigger. 8.84 plus 9.768. Okay, this is 18.608. So once again, a glance back at the previous number. This total was 18.48. Now we've got a higher one. So how I want to quantify the difference. The difference is 18.608 minus the previous 18.48. That's a difference of a positive one of plus 0.128. Okay, that's brilliant. On the other hand, the offsetting effect is that due to the fact that we have a higher yield, we sell the bond for a lower price. There is an inverse relationship between bond prices and yields. So we actually suffer a capital loss, right? Because we sell the bond below its carrying value. And the carrying value is the value that would come from that constant yield price trajectory. And we have somewhere over here before, that price, the carrying value over here, 90.263 for which the bond was sold beforehand. Now it was only sold for 88.027. So the difference, and it's going to be a negative one this time, is selling the bond for 88.207 versus the prior 90.263. I believe I got that number right. Let's see, 88.207 minus 0.263. Okay, it's a right, I think I got that one wrong actually. Yeah, I got this number wrong. Apologies. Let's go back here and check it. No, it's 88.027. Right, I knew I was staring at the wrong number. 88.027 minus 90.263. Okay, now it's good. This produces a negative effect of 2.236. And as you can see, that negative effect over here, this one, absolutely trumps the positive effect from having the coupons reinvested at the higher rate. So if we net them, you get a negative overall 2.108, let's say overall or net. And this is why, over here we've got total year 3 cash flow of 114.635, whereas before, without any yield change, we would have had 116.743. 116.743. If we quickly do this difference, 114.635 minus 116.743. Yeah, same result, same difference, and it is unfortunately negative, hence lower horizon yield in this case. Right, let's see if we can answer the question. Right, the question is answered by picking answer C. That was the horizon yield, 9.33. And let me just now summarize what we kind of discovered in this lesson. We've done a lot of computation, but it's important now to take a step back and take a broader view of things. We focused in this lesson on what is officially known as interest rate risk. The risk that interest rates will change, and for fixed coupon bonds that has a twofold effect. On the one hand, it materializes in the form of reinvestment risk. And that's obviously to do with how you reinvest the coupons. So if interest rates, I/R is how I often abbreviate interest rates, so don't be sort of surprised to see me write this down, right? If interest rates go up, like they did in this case by 50 basis points, right? The value of the reinvested coupons goes up as well. Nice. However, there is the other aspect of interest rate risk, and both are, extremely important. The other aspect is something we call price risk. Okay, price risk. Because that interest rate going up will have the effect of making the selling price of that bond go down, obviously below the carrying value. If yields remained constant, the price of a discounted bond would actually be slowly moving up due to the amortization of discount. But here we talk of a drop below carrying value, and of course, this is only true if we have a bond that matures beyond our investment horizon. If it matures within our investment horizon, we get to that nice round 100. And the question is, which effect is going to be bigger, right? Which one will outweigh the other? And some of these risks, or these two elements of risk, are more important for some investors, whereas the other is more important for other investors. For example, this one, the reinvestment risk aspect, is going to be, I guess, more important for investors with longer term horizons, because then the effect of reinvesting the coupons will have a big impact on their horizon yield. Whereas if you're just dipping into bonds, buying them for a short period of time, there is not really going to be much of an opportunity to make money from a coupon reinvestment. You're going to be more focused on the price risk element, so more important for, let's say, shorter horizon bond investors. And of course, the same instrument may, giving exposure to different types of, or different dimensions of interest rate risk, what investors feel really varies with their investment horizon. Some feel more exposure to one type of risk, the others feel more exposure to the other type of risk, and it really does depend on horizon, as I said.